Alright, so now we're going to look at our actual periodic table in our notes and add a few things to label your periodic table. If you haven't already done it, add an arrow that's going up and down on your periodic table and add the words groups and families. You need to know that the vertical columns, that's the up and down, are the groups or families on your periodic table. Also add an arrow going across left to right with the word periods. And since this periodic table is not numbered, go ahead and number your periods from 1 through 7. There are 7 periods on your periodic table. Now we're going to take a look at group 1 and look at their Bohr models. So the first element in group 1 is hydrogen. And hydrogen is kind of an anomaly. It's its own thing. It's a non-metal that's on the side with all of the metals. But if you draw a Bohr model for hydrogen, hydrogen has 1 proton, no neutrons, and 1 electron. So hydrogen has 1 valence electron. The rest of the elements in group 1 are all our alkali metals. Lithium has 3 protons, 4 neutrons. So it has 3 electrons, so 2 in the first energy level, and then 1 valence electron. Working our way down, sodium would be the next alkali metal. Sodium has 11 protons and 12 neutrons and 11 electrons, which would give it 1 valence electron. And if we were to draw Bohr models for every element in group 1, you would find that every element in group 1 has only 1 valence electron. So on your periodic table, make sure you note at the top of the column that everything in group 1 has 1 valence electron. Looking at group 2, very similar. Beryllium has 4 protons and 5 neutrons, so it has 4 electrons and 2 valence electrons. The next element down in our alkaline earth metals is magnesium. Magnesium has 12 protons, 12 neutrons, and 12 electrons, which gives it also 2 valence electrons. So if we were to continue down group 2 or column 2 of a periodic table, we would find that all of these elements have 2 valence electrons. So the second column, group 2, all has 2 valence electrons. Make sure you note that on your periodic table. Now, groups 3 through 12 are what we call our transition metals. They're the middle part of our periodic table. They are our short columns. We're going to skip over these when we're looking at our Bohr models, because transition metals are called transition metals because the electrons like to transition between energy levels, and so that means that their valence electrons don't exactly match our typical Bohr models. And so on our last worksheet we talked about most transition metals have 1 or 2 valence electrons, and when you get into high school and you start looking more into those, you'll be able to see more of what the valence electrons actually look like. But for this year, we're just going to skip over columns 3 through 12. All right, if we look at group 13, boron is our first element, and that's got 5 protons, 6 neutrons, and 5 electrons. So we have 3 valence electrons. The next element in group 13, or the boron group, is aluminum. And aluminum has 13 protons, 14 neutrons, and 13 electrons, which means it also has 3 valence electrons. If we were to work our way all the way down that column, or group 13, we would find that everything in that group has 3 valence electrons. So you can just ignore the 1, and that group 13 has 3 valence electrons. Group 14 is our carbon group, so it starts with carbon. Carbon has 6 protons, 6 neutrons, and 6 electrons, which means that it has 4 valence electrons. Moving down group 14, next is silicon. Silicon has 14 protons and 15 neutrons and 14 electrons, which means that it has 4 valence electrons as well in the Bohr model. So if we were to go through all of group 14 and draw out all of the Bohr models, we would find that everything in that 14th column has 4 valence electrons. So just like group 13, we can ignore the 1, and it's got 4 valence electrons. Group 15 is our nitrogen group. So it starts at the top with nitrogen. Nitrogen has 7 protons and 7 neutrons and 7 electrons. which if we draw our Bohr model, it has 5 valence electrons. Next in group 15 would be phosphorus. And phosphorus has 15 protons, 16 neutrons, and 15 electrons. So drawing out the Bohr model, we have 5 valence electrons. So if we were to draw our Bohr models for all of group 15, just like before, we would find that all of our nitrogen group, or group 15, has 5 valence electrons. Now make sure you're labeling your periodic table with the correct number of valence electrons. In group 16, our oxygen group starts with oxygen, and oxygen has 8 protons, 8 neutrons, and 8 electrons. So if we draw out our Bohr model, we can see that there are 6 valence electrons. The next element down in the oxygen group, or group 16, is sulfur. Sulfur has 16 protons and 16 neutrons and 16 electrons. So drawing out the Bohr model, there are 6 electrons in that last energy level, or 6 valence electrons. And just like in our other groups, at the top of group 16, you can add 6 valence electrons, because everything in group 16, if we were to draw out all of the Bohr models, they would all have 6 electrons in their outer energy level. All right, group 17 is our halogens. Remember our salt formers. They start with fluorine. So fluorine has 9 protons, 10 neutrons, and 9 electrons. So there would be 7 valence electrons in fluorine. Our second halogen would be chlorine. Chlorine has 17 protons, 18 neutrons, and 17 electrons. So if we were to draw out our whole Bohr model, we would find that there are 7 valence electrons in chlorine as well. So once again, at the top of our column 17, our halogens group, you can note that there are 7 valence electrons in every single one of our halogens. Our very last group is group 18, or our noble gases. Neon is one of our noble gases. It has 10 protons and 10 neutrons. So if we draw the Bohr model, you'll see that that has 8 valence electrons. Argon is also a noble gas, and you'll see that that has 18 protons, or 22 neutrons, and 18 electrons. And so if you draw out that entire Bohr model, you'll see that there are also 8 valence electrons there. Also, one of the noble gases is helium. That's the very first one in the column. Helium only has 2 electrons. It has 2 protons and 2 neutrons as well. So helium only has 2 valence electrons. Helium is a special one for group 18. Most of group 18 has 8 valence electrons. And really all of group 18 except for helium has 8 valence electrons. Follows that same trend as the rest of the periodic table. Part of what makes a noble gas inert or non-reactive is that its outer shell is full, and that's the important part about that noble gas column. That's why helium is there. Even though it technically doesn't have 8, its outer shell is still full with only 2 electrons. So helium only has 2 valence electrons, but everything else in group 18 has 8 valence electrons. Now, you want to make sure that you have all of these labeled on your periodic table, because it's much, much easier to just look at your periodic table and look at the column number instead of having to memorize or draw out the Bohr model for every single element. So this way you can look at an element and know the valence electrons without having to do math or draw the Bohr model.